8.3 looks at what is known as the activity series of elements. And for the activity series, we're really looking at how reactive an element is compared to another element. So you can see here we've got fire, so there's some type of reaction. So activity, how able or how easy does an element react with something else? We have what is called the activity series, which is a list of elements, and it organizes those elements in order of most reactive to least reactive and what type of things they can react with. Some things react in water, some things react with metals. So we're going to organize them based on how reactive they are. So if we look at this, the first column, we have metals. So you can see they decrease in activity. So lithium is the most reactive, all the way down to gold. And so you can see some other things that are probably familiar: copper, silver. We're not going to want things that we make jewelry out of to be reactive, because if we put on a gold ring and it were reactive with our skin or even water, that moisture in our skin, that would be a problem. If we look at the second column, the halogens, so these are going to be something from group 17. So those also have an order of how reactive they are. So fluorine's the most reactive down to iodine. When we're looking at reactions and using this chart, the metals are going to be our cations or positive atoms that we'll be looking at, and the halogens will be the anions, the negative ones. So the most reactive are at the top, and they can replace something that is down below. Lower elements are not going to replace something above. And so we're going to look at being able to determine if a reaction will actually occur. Sometimes when we mix two substances, they will react and sometimes they won't. So we can determine this based on the activity of what we're trying to combine. So the first thing we have to determine is which element is going to be replacing the other. So Br would make a negative charge. It's in that group 17. So it would have a -1 charge if it were to be an ion. So it will replace the negative element in this compound, which would be iodine. So since that's the case, we're going to be comparing bromine and iodine. So we're going to look at the chart here. Bromine is higher on the chart than iodine. So that means that it will react and it will replace, and we will have a single replacement reaction here. So iodine would replace bromine, and it is diatomic. And then we'll have K with the Br, and that would be the reaction that would occur. The next, we've got Au, which is gold, and it would be positive, so it would replace the hydrogen. So if we come over here, we find hydrogen and we find gold. Gold is down below, so this will not react. So we would just write no reaction. The next one, we have magnesium. So we can find magnesium on our chart. Let's get rid of those. So magnesium is here, and it would replace the CO because this is positive. CO, because it's first, is we know it's positive. So cobalt. And let's see, cobalt is not on our list, but actually magnesium is higher because cobalt's down below. I can tell you that. So this would replace. So the CO would be out by itself. And then we would put Mg with the NO3. And this is a +2. So when we crisscross down, we'd get the same thing. And that would be the reaction. So the thing you need to keep in mind when you're given the elements or the reactants to identify, are they going to react? You're going to first, the one by itself, determine is it positive or negative, then figure out which one it would switch with. So since this is positive, we compared it with the other positive. Since this was negative, we compared it with the other negative. Then look at your list. So these are the positive ones, these are the negatives. And if the element by itself is higher on the chart, you will get a reaction.